So let's get back to the deuce model. As we mentioned, the deuce deal with the distance, elevation, watershed, and slope unit, which we consider are the most reasonable and logical relationship that it can connect the landslide occurrence with its related station. Also, it can remove the stations that are not logically correlated. For example, as we said, in the CTRL, the internal relationship, that means the attribute, that means the tool will scan internally those stations. So it will look into the occurrence of the events within the days, in hours actually. It's looking within hours where the event happened, and they match the landslide occurrence with those stations. And if there are no occurrence within that, there were no record within the time of the occurrence of the landslide, it will just simply remove this station. But in here we are dealing with those stations who are giving a record, but this record is not the actual record. It's giving, like, for example, if the nearest, or it's the most suitable station said the occurrence happened within like let's say 40 millimeter or 50 millimeter for like 6 hours, this station that is not related based on our hypothesis here, it's giving maybe 10 millimeter. Okay, but this is the 10 millimeter. Later on, if we choose this station and we process, it will increase the uncertainty in the result. So you will always suspect whether maybe 10 it's good to give us landslide or something like this. So we get to those, we call the filters now, so, or the criteria. So the elevation, about the elevation and distance, many studies have recommend using the nearest distance. Okay, and most of the studies using the nearest distance, as we mentioned earlier. However, in one study mentioned that for few landslides, elevation was considered more important than the geographic distance to the landslide. Okay, and this is, we will come to it in the next slide. In the watershed, the issue that, what is the watershed? It's as small as a footprint or large surface area that drains all the streams and rainfall to a common outlet, such as a reservoir. This is the watershed. Okay, it's a large surface that it has all the streams within it to the common outlet. So in a different word, it includes the features that share similar condition of soil moisture content. Okay, because all they drain together. And variation in the groundwater level and the basin volume flow. And this is as mentioned by Jane et al. 2007. Where the rainfall amount outside the surface watershed is considerably larger than the rainfall amount within this watershed over same period. And it's also logically, because if you have two watersheds and they have the rainfall event at the same time, you never expect similar amount of the rainfall on the two watershed. And I'm talking case if we have large landslides or like huge basins, or they are like having significantly different elevation. Okay, but in the small landslides, the like 10 meter body of the landslide, that those watershed, it's considered to be a very small area, maybe like, for example, a 400 square meter or like 1000 square meter. This is not a huge area that you can say that the watershed can differ from the neighbors. I'm talking about the huge watersheds. Also the slope unit. The slope unit, as we have the tool that we developed in a different course, we call the Lagriso. That is what we will use here actually, but it will be embedded within the filters. So the slope unit is the smallest homogeneous surface that are highly relevant when addressing any hydrological and morphological differences within the surface. So when we have a landslide in this slope unit, and some people they try to imagine the slope unit as its aspect. You know, when you develop the aspect map, or the aspect that when you give the point here and you give the other directions, when you start from north and you come here to the, and here say northeast, and you give the east, and after that you have the south, east and south. Okay, so this is the aspect within the direction of the sun, that this is the facing the sun, which direction is facing the sun. Okay, so in here we consider this slope unit. It's even smaller than the aspect, because within this aspect you might have 2 slope units. Okay, so the slope unit itself, it's very precise now filter. Actually we added in term of, we have a very highly density of the rain gauges, but in most of the cases we won't reach to this filter, because most of those stations are allocated almost in the similar watershed or within specific elevation. But slope unit, it's very small filter, that if you face the issue that you have a landslide occurred within watershed, within a specific slope unit, and this station is in here, so definitely this station related to this landslide. Okay, so in short, this tool, the Deuce, it's improving the threshold reliability by optimizing the topographical, hydrological settings of the landslide event and rain gauges from macro to micro. Okay, so here is the micro. Okay, and we go to the macro, the more general, and it's recommended. Here is the example about the distance, the elevation to distance. If you look here, this is coming from the Google Earth, and consider those red dots as the landslides. Okay, so you can just plot it and you can see. Now those blue dots represent the rain gauges. Good. All right. Now if you start any research and you have those 2 landslides, okay, what you will say that when I choose to find those related rain gauges to get the readings about those landslides, I would choose the nearest based on the common research. But if you notice here, this is the nearest station to this landslide. But if you come to here, you notice that this station to this landslide, it's closer than this one. Yes, definitely it's closer, which is in the term of a distance, okay, you have 1.3 miles. But if you look to the profile, in here, look to the profile that this point, actually here, we are just taking this point, which is represented by in here. There are a great mountain or the difference in the elevation between in here, which is in this point. Look to the end of the line represented by in here, and this point, it's this one, and you take the section, okay, and you are moving, you are coming close in here. Look to in here, look to the differences now in the elevation. So what happened, that we can understand that this difference, which is reached to almost 1,600 feet between, as an obstacle between the landslide and the rainfall. So can you imagine what kind of different behavior and different water contained between this region and this region? This is giving us a very big question mark that whether we can consider this station as even the wind condition, it can differ between these two areas. While if we come to the station that it's located in this part, which is in the almost, if you see this, it's the city. Okay, this is the city here near to the coast, and in here if you see this valley, and this is again the landslide that we talk about in the previous slide. You see here there is a gentle elevation or gentle obstacles between this area. So you can imagine that we might have one big basin like this. So in all of the condition that it can be seen here, it can be similar in term I'm talking about in term of the moisture contained if we have one rainfall event. Yes, this one is rationally far, it can consider to be, because it's 2.6 mile and here it was 1.3. Okay, it's almost the double of the distance. However, there are no significant obstacles between this area. So in terms of, let's say, the rainfall event and the moisture contained, okay, this area is much more related, okay, to this station. But in here it's following the different basin. If you see here also in this different place. Okay, again we will, when we extract those stations, we say that the nearest the one that start from the slope unit, it's the most preferable. If we couldn't find within the slope unit, we search within the watershed. If within the watershed we couldn't find, we search within the elevation. If the elevation we couldn't find, the last filter is the distance, which is the common one. Here we are just optimizing the selected station. So we come to the objectives, then the criteria that of the deuce that is built in QGIS software. Apply multiple filters like the distance, elevation, watershed, and slope unit based on the similar terrain condition, macro to micro. And what is kind of data that we need to deal here with this tool? We need just the dam of the study area, landslide inventory, and your, what we call it, your landslide. So the rain gauge, the landslide inventory, and the dam. So just three kind of information. Using this, it's just we need the location for the deuce, because later the attribute will be used for the deuce. Here we need the location of the rain gauge and the landslide inventory, and here the dam. What kind of parameters that we will use later? We will just use something like the raster resolution, that you know already what's your resolution of the dam, or what the resolution you are looking for in the future, because in the huge study area and you are having dam within 30 meters, actually it won't be useful, as you know this relationship between the scale and the size of the study area and the resolution of the raster. And also the search radius, you need to consider this, and limits for the altitude difference. For example, you said that the best is within, like, for example, 100, and different research actually said if it's within the same elevation or the same altitude, it's the best. But actually this is very difficult to find a landslide happen within the same elevation of the station, even though it might be possible in some cases, but we should give a little bit some distance in the difference in this altitude considered to be like allowable difference. Also, we need the minimum area of the single basin. So all of those parameters, we will talk about them in details when we use the tool.